Before this announcement is made, the Nobel Prize laureates, or at least they try to be contacted via phone. The Nobel Prize Committee tries to contact them to tell them that they won and to make sure that they're available for a phone call during the announcement itself.
So you only get to hear this like a little bit in advance, and then all of a sudden you have to answer all these questions about your research, and you are all of a sudden a winner. That's really cool.
Yes, and depending on the time in the world where you are, this could be middle of the night for you. You're just called awake. So yeah, that's always fun.
And you just have to pick up your phone, I guess.
Yep, which not all the laureates did.
Welcome everybody to the 66th episode of the Struggling Scientist podcast. We are a podcast by scientists, for scientists, anybody science adjacent, and perhaps even hobbyists. My name's Suzanne and I'm here with my co-host Jayron.
Hi.
Today's episode is all about the Nobel Prizes of 2023. The Nobel Prizes were announced from the 2nd until the 9th of October, and we will be discussing who won, what their topics are, and of course a little bit more about the science other scientists might be interested in. Tune in to this episode for everything you need to know about the Nobel Prizes as a scientist. So the Nobel Prizes, Jayron here followed them the announcement at least very, very closely. Can you tell us a little bit about what the Nobel Prize process actually looks like? I think these were the announcements, and the actual award ceremony is in December, if I'm correct?
So indeed, the award ceremony is in December, more specifically the 7th of December, where hopefully all the Nobel Prize laureates will actually be present in person there to accept and also give a short presentation about their work. I think, well, maybe with the exception of one, I think they'll probably all be there. And let's see. So the actual process looked a little bit different depending on what award was being given. So for all of them, there's a committee of people that are kind of hush-hush about the whole process. And there were even questions about what the process of deciding who gets a Nobel Prize actually looks like, but they couldn't give any information on that. But so for example, for the more scientific awards, the more medicine, physiology, chemistry, and stuff like that, there were usually 3 members presenting it. I think he's the head of the Nobel Prize Committee, and 2 other sort of more scientist people, one to give a more general explanation about the topic, often with some illustrations, and the other one to give a more formal presentation explaining what the application of this research might be and more the detailed science behind it.
Interesting, because that's of course not by the
Scientists
winners themselves, because they don't know yet until that moment. So that's interesting that then somebody else is giving a presentation about that. Cool.
So also before this announcement is made, the Nobel Prize laureates are, or at least they try to be contacted via phone. The Nobel Prize Committee tries to contact them to tell them that they won and to make sure that they're available for a phone call during the announcement itself. This did not work out for all the Nobel Prize laureates, but for some of them it did. And then after the announcement is made, the presentations are done from the people there. They are called, and then the laureate can answer questions for the press there. This is not the case for all the prizes because, for example, the Peace Prize and the Literature Prize, there was only one person telling what the body of work of the person who won it was, instead of like a formal presentation about their work. So
okay.
Yeah.
So you only get to hear this like a little bit in advance, and then all of a sudden you have to answer all these questions about your research, and you are all of a sudden a winner. That's really cool.
Yes, and depending on the time in the world where you are, this could be middle of the night for you. You're just called awake. So yeah, that's always fun.
And you just have to pick up your phone, I guess.
Yep, which not all the laureates did.
No, and there's also no group of people who are selected. Like in some prizes, you have potential winners, and then they all show up to an event, and then there you hear who won. That's not the case here. You only have the winners, basically. You don't know who else was considered, right?
No, but I have heard that there are sort of these, sort of like the Eurovision Song Festival, where there are people who think like, oh, this person should be eligible for the Nobel Prize and is likely to win and stuff like that. And we'll actually touch on that later. That there was one laureate who was put on that list for 10 years, but he never won until now. So there's sort of like people who are...
So is the list known?
But these are not from the Nobel Committee themselves. These are from like the people who are sort of who are trying to predict who the Nobel Prize winner is going to be. like that.
Okay.
Like that.
So the actual people who were considered for the Nobel Prize, other than the winners, are not known.
No.
Yes, okay. So you could watch the announcement live.
Mhm.
Can you tell us what they were like? Are there any things that stood out to you from the announcement? I believe there's also press questions at the end.
Yeah.
What was that like?
Yeah, no, it was very interesting, but it's also interesting to remark on the differences. So normally these things are kept very hush-hush until like the actual announcement. But for one of them, it was leaked apparently. And yeah, so they were immediately after the talks there, the press went into how do you think this was leaked? So it really got diverted to all that. But for the most part, the entire thing is very formal. It's very doors open, like these halls with like paintings of people on it. The press is situated around tables, ready to film everything and ask questions. And for the scientific ones, it was, again, like I said before, the three people who were talking, both in Swedish and in English, at least for the introduction of like the prize goes to this person in Swedish first, then English. And then the two people could give the explanation about the actual science. And then they would answer questions as well there if, for example, the laureate did not pick up the phone.
Yes.
Yes. So
were there any people who didn't get the original call but then did pick up the second time during the actual ceremony?
Not that I'm aware of. I think
that would have been funny.
I do know that there was one person who said they were actually on a holiday or something, or like on vacation in Mexico, and that's why they would not pick up the second call, but they were happy to be awarded the prize, of course.
What?
Yeah. But there were also three people from that prize, for example. So they
okay.
I think they contacted the other two, and
Yeah, how many people on average won a prize? Is it always multiple people? How big is the team?
So it can vary quite a lot. So sometimes it's people who didn't work together at all, but built on the work from previous people. And other times it's also, like in the case of the medicine one, those two people worked very closely together for years. But yeah, it can differ a lot between the different teams. And sometimes they don't even know each other. They just, or at least in person, they just built on each other's works a little bit.
Okay. Well, I think that's enough background information. Let's dive into the actual topics. Now, there are different categories. Can you tell very quickly which ones are they?
So the different categories are physiology and medicine, physics, as well as chemistry, literature, peace, and economic sciences.
Okay. Why don't we just get right on with it and you can announce the first Nobel Prize winner, who they were and what their science was?
Yes. The first prize was the Nobel Prize in Physiology and Medicine, and it went to Katalin Karikó and Drew Weissman for their discoveries concerning nucleoside base modifications that enabled the development of effective mRNA vaccines against COVID-19. So they spent years researching the use of mRNA in vaccine development and had some struggles along the way, such as for some reason the mRNA made in vitro resulted in immune responses, which were not good for use in vaccines, while native human mRNA did not result in immune responses. And eventually, in their paper in 2005, they showed that you could prevent the immune response by adding base modifications to the in vitro made mRNA, thus making them much more suitable for vaccine development.
Yes, very interesting. And without this research, we of course wouldn't have had a vaccine so quickly and such a good working one. Tell me a little bit more about these scientists.
Yes, so Katalin Karikó began her career in Hungary, and eventually she moved to the US at UPenn University. There she met with Drew Weissman, who was also a researcher there. So Katalin was more focused on the research of mRNA and mRNA chemistry and biochemistry, while Drew Weissman was more focused on dendritic cells, or DCs, and priming them for immune responses to use as vaccines. And together they started researching. And eventually what they worked on was combining their two research specialities, namely mRNA research and vaccine development with DCs to exploit their antigen presentation potential. But this had problems because as they were working on it, they saw that by just making mRNA in vitro and presenting it to dendritic cells, this would either elicit an immune response or it wouldn't. eventually, through a lot of research, they could see that by adding the mRNA with some base modifications, such as pseudouridine, you could completely get rid of the immune response that these cells would result in, and thus making them more able to be functioning as antigen-presenting cells and actually be potentially used as for vaccine development.
Okay, well, that's very cool that they worked together so much and that they made such an amazing discovery together as well. It's always cool when scientists from different disciplines come together. So in the end, what they did was make uridine.
So they tried different base modifications, and one of the biggest ones was the pseudouridine modification on the mRNA. Because, again, for some reason, if you make mRNA in vitro, it lacks these modifications. Whereas in humans, it did have these modifications, and that's why human for mRNA, for example, would not lead to an immune response.
So these are post-transcriptional modifications normally. Okay, and there were also a couple of other ones that were really important too.
Yes, but one of the biggest ones was the pseudouridine. Yeah.
And that suppresses then the immune response. And of course, if you get an immune response and your RNA already gets broken down, you will never get the actual protein that you want the immune response to be to.
Exactly.
Vaccines. So yeah, very, very important.
Yes.
Okay, now I've heard already about her, of course. And there were some interesting things going on here.
Yes. So Katalin is a very interesting person, and her path towards getting from researching mRNA all the way to this Nobel Prize has also been quite an intense one. So she started in her own group in the Department of Neurosurgery at the University of Pennsylvania already in 1997. Yes, neurosurgery. I also wouldn't have guessed that.
Okay.
But that's where she started. And she was always interested in mRNA, but she didn't really manage to get a lot of grants during her research. And eventually this ended up, I guess, leading to UPenn demoting her, eventually even reducing her from like a tenure position to more adjunct professor position.
And when was this?
Between the late 1990s and 2000s.
Okay, so in 2005, the paper came out that okay, so this was before that, okay?
Yes. So, eventually she also moved to Germany. And there's a lot of different areas to cover here with her life. So, for example, completely unrelated to her scientific field, she also has a daughter, and that daughter is a 2-time Olympic rowing champion, gold medalist.
Okay.
And they're also starting a company now together.
In what?
That I'm not sure about. So they haven't started a company yet, but she also has a degree in MBA. So
the daughter or
the daughter? Yeah.
Yeah. Okay.
Yes. So that also is happening, and now with this recent Nobel Prize and all the other prizes she's won in the last couple of years, now that the mRNA stuff has really come to light. She also wrote a book recently that came out.
Oh, that's cool.
So a lot is happening in the same time period for Katalin. And I think what's important to mention is when the first clinical trials results were coming out for the vaccines, the mRNA vaccines, she was not at all surprised that they were doing well. And she ended up celebrating the results from the clinical trials with her favorite chocolate, Goobers-covered peanuts.
Okay.
And she told CNN that I'm not an exuberant person. So she's also very modest and very down to earth.
Okay. Cool.
Yeah.
Very cool. Interesting that you can have such an tumultuous career basically in science and then still find something that wins the Nobel Prize. Yeah,
and it's something that I struggle with understanding it, because it's very clear just from the research that mRNA vaccines had a lot of benefits if you could get them to work, because you could make them faster and you didn't require huge cell cultures to get enough of the stuff to actually work.
And if I look at the timeline, she was already working with the Drew Weissman, the other winner, in the late 1990s. So that is the time that UPenn decided to demote her for not getting enough grants. But at the same time, I would say it's more of a problem of the brand committees than not recognizing that this is really important research to be done. Then, I mean, I would more blame them, to be honest.
I guess, but at the same time, it's sort of awkward as UPenn University to demote someone and basically fire them to the point where they just have to work as an adjunct professor.
Mm,
But then the moment they win a Nobel Prize, like, hey, she's our great scientist, and we always believed in her.
That is for sure awkward.
So that's what led to a lot of controversy on Twitter
Mm,
and other social media platforms, for sure.
yeah.
And
But at the same time, like this fundamental research, which this obviously also is,
Mhm.
is often not recognized until there's actually like a proper
result and impact on
impact. And it's hard sometimes to visualize what this research will actually lead to. But it's super important.
Mhm.
As a fundamental scientist myself, I am I feel about this. But yes.
Yeah, and I think both the collaboration of Kathleen and Drew really goes to show that you need different people to work on something, and you really need to keep an open mind about things. They also mentioned a lot in their interviews that they're very different people. Kathleen is much more, as she herself and Drew described her, zigzagging through different ideas, whereas Drew is more like focused. He's more of the scientist person who goes like from A to B, like making connections. And so those different mindsets and those different approaches, I think, really also helped in their collaborations, and they worked well together.
Well, I guess this is time to move on to the next category then.
So the next Nobel Prize is for physics and was awarded to Pierre Agostini, Ferenc Krauss, and Anne Hullier for experimental methods that generate attosecond pulses of light for the study of electron dynamics in matter. So these laureates are being recognized for their experiments, which have given humanity new tools for exploring the world of electrons inside atoms and molecules. They demonstrated a way to create extremely short pulses of light that can be used to measure the rapid processes in which electrons move or change energy.
Okay, that sounds interesting. Not something I fully understand. So can you give me a little bit more background on that?
Yes, so electrons move very quickly.
Mm.
And in the world of electrons, it's sort of measured in attoseconds. And to give you a perspective of attoseconds, that is, so you have 1 second, and an attosecond is 0.1 with 18 zeros before it. That's
that's quite a lot of zeros.
Yeah, so that is a very small amount of time. And to give you more perspective, 1 second to an attosecond, that difference is the same difference as 1 second to the amount of time in the entire universe. So you're basically on a universal scale from 1 second to an attosecond.
Okay.
So a big difference.
Mm-hmm.
And before, it wasn't really possible to measure or like image anything when it came to electrons in that space. It wasn't really possible to do anything there. And what their research and their contributions to the field have done is to find a way to create these attosecond-like pulses of light so that you can actually measure electrons and image electrons in a way. So to give you, I guess, an example, it's sort of like, have you ever seen like a fan on the roof sort of move very fast that you sort of see a blur? And if you put like a flashlight against it, you can sort of see the remnant images of like it moving slower.
Mm-hmm.
It's basically like that. They sort of created light pulses that let you sort of see the electron then slower.
So it's an extremely short light pulse, but not as short as actually like 18 zeros, right?
Yeah, so it basically slows it down that you can actually see it a little bit. So what they specifically did was they worked independently of each other across their time span. So the first one, Anne Hullier, discovered that you can create this sort of attosecond light pulse by combining different light sources, light overtones. And light moves in waves, and they have a wave function. So if you overlay those waves on top of each other, you get certain peaks where they amplify each other, and certain places where they sort of destroy each other and it sort of levels out.
Okay, yeah.
And that you can sort of, if you sort of create an attosecond pulse, which has...
How many attoseconds?
It depends. So the later two Nobel Prize winners created a light pulse multiple light pulses that lasted 250 attoseconds, and the other one did it with only a single light pulse that lasted 650 attoseconds.
Okay, yeah.
But that was all built on the initial work from Anne, and these other two also did it independently. In the same year, they published their paper. And yeah, one looked at multiple light sources and created multiple pulses that lasted 250, while the other one created one light source that lasted 650.
Okay.
And since then, there have been improvements on their research, of course, but they really laid the foundation for being able to, do this kind of these experiments at all at the attosecond level.
Yeah, for sure. And when was this published?
So Anne published it in 1987 already.
Okay.
And Pierre Agostini and Ferenc Krauss published both in 2001 independently of each other with their different
and all
techniques.
three of them are now awarded this because they build on top of each other's research. Okay, cool.
Yeah.
Different methods also.
Yes.
Will be interesting once we start to visualize electrons moving.
Yeah, so to a certain extent, at least experimentally, that's already being used and is really giving us some insights there. And the applications for this are apparently, and I'm not a physicist, but it could help with the ultra-fast switching of materials like a silicon dioxide from being an insulator to a conductor, apparently. It can also enable faster electronics, which always nice.
Always nice, yes.
Yeah. And this could be more biochemical or biomedicine related. But apparently you can also potentially use this type of technology for analyzing samples in blood to really see small changes in the blood that you would not be able to see with any other methods. But this is still being developed and is probably a long ways away.
Okay, very cool though.
Yes, and maybe some fun facts.
Of course.
Anne Hollier was, when she was called about it, she didn't pick up the phone. This was not during the ceremony, but just to tell her that she won. She was in the middle of an engineering physics class with about 100 undergraduates, and she just sort of turned off the call. It's like, yeah, no, I'll get back to it after I finish my class. And even when she picked it up, she checked during the break, and she just went back to teaching. It's like, okay, but I really need to teach.
Okay.
And during the actual announcements, they asked her about it. It's like, so we called you during this. It was very like, what does teaching mean to you and stuff like that? And she was like, I was just very concentrated about teaching, and teaching is very important and stuff like that. So it was really nice to see someone who both focuses on the science, but also the teaching and communicating that science.
For sure.
You know, and her university also celebrated her receiving the prize, because the moment she walked out of her one of her classes, there was an entire row of people like clapping, filming, like congratulations and stuff like that. So that was nice to see as well.
It must have been the same class almost then, because...
Yeah, I think she got called during class, so I think so, yeah.
Yeah, cool.
Yes.
Very cool.
Yeah.
Okay,
Yes.
time to go on to the next category.
So the next prize is the Nobel Prize in Chemistry and was awarded to Mogi Bawendi, Louis Bruce, and Alexei Ekimov for the discovery and synthesis of quantum dots. Independently of each other, Ekimov and Bruce succeeded in creating quantum dots, and Bawendi revolutionized the chemical production. Everyone who studies chemistry learns that elements' properties are governed by how many electrons it has. However, when matter shrinks to nanodimensions, quantum phenomena arise. These are governed by the size of the matter, and the Nobel Prize laureates have succeeded in producing these particles that are so small that these properties are determined by quantum phenomena.
Okay.
Yes.
Cool.
Yeah, so I guess you will do like a little walkthrough.
Yes, please.
Yes. So, for example, fluorescent proteins, you get different colors based on completely different structures.
Mm-hmm.
But when you get to sort of quantum dots, you actually have the exact same molecular structure, same atoms, but just by shrinking the size of it, you can get a completely different color. And this not only, because this
So it's a molecule.
Yes.
Are we talking about a molecule scale?
I think even smaller than that, like individual layers of atoms. And it's very precise because this actually influences the electrons, and the less space the electrons have, the more energy they release. So less space, more energy, it can emit like a blue light. More space, less energy in that space, red light. And it's the entire spectrum of colors.
So is it an element?
It focuses, the particle that holds the electrons is an element. So it could be like gold or cadmium, and I think there are others as well. And you really need to very precisely determine how many atoms you put together to influence how much space the electrons have and what kind of how much light or what kind of light you get out of it.
Okay.
So this is important for, I didn't know this, but QLEDs for your screens, the really high quality screens. The Q stands for quantum dot LEDs.
Oh,
Yeah.
okay.
So that's where one application of this technology already, where just by using these materials and depending on how much space you give your electron, you can change the color of
Cool.
the thing. Same atoms, same properties, everything.
Mhm.
Just you somehow manage to change the colors by the energy of the electrons.
Okay, and so this is already being used. When was this developed? When was this research published?
So already in the 1980s, both Ekimov and Bruce were developing, at least in the lab, the early techniques to sort of make these particles that emit the varying colors. And it was in the 1990s that Bawindi actually came along and developed the new chemical methods for producing and making these particles more uniformly and quickly.
Cool.
Yep.
And it's already being used and everything. That's cool.
Yes. And I should mention that because these electrons can influence a lot of different properties of the particle, right now it's only being really used for influencing the light, whether it's emitting blue light or the entire spectrum going to red light. But you can also influence the melting point of the thing. You can also influence whether or not it's magnetic, whether or not it conducts electricity, a lot of different things. But that is still so. What I liked about this presentation when it was being announced is that the person who gave the detailed talk really mentioned that, yes, while this technology is already amazing for what it's doing, a lot of the future applications will probably be even more amazing.
Okay, well, very interesting to see. Not sure if I 100% understand how they did it, but it is very cool. And yeah.
Yes.
Was there anything else mentionable about this announcement?
Yeah, so some maybe less fun facts. So this was the award that actually got spoiled a few hours before the announcement. So 4 hours before the announcement, the names of the winners were already leaked. And it's still unclear how this exactly happened, but the Nobel Prize Committee is trying to make sure this never happens again.
Okay.
And another less fun fact is the journalists as well during the announcement asked a lot about one of the recipients, because one of the recipients was born in Russia, and we're asking about whether or not we should be recognizing Russian scientists in the Nobel Prize.
But did he do the research in Russia?
No, he's been outside of Russia for over 24 years. Well, that I don't know, because he's been outside of Russia for 24 years, but I don't know if the initial research that he did, which was already in the 80s, was in Russia.
Yeah, okay. But he left Russia.
Yes, he's definitely left Russia, and to my knowledge has no more contacts with Russia.
Okay.
So
difficult point, yeah.
No, for sure. So that a lot of things behind the actual Nobel Prize and the actual research happening here.
Okay. Let's get on with the next one.
Yes, so the next prize is in literature and was awarded to John Fosse for his innovative plays and prose which give voice to the unsayable.
That sounds interesting.
Yes, so I am not much of a literature buff, and certainly not in the Norwegian language, which he writes, and more specifically in I guess it's a dialect of Norwegian that is one of the more minority dialects in Norwegian, which he writes in as well, as sort of like this act of rebellion, or at least that's what his native tongue is. So he writes in Nynorsk,
okay,
which is a very minority language in Norway. And yeah, so it's not widely used, but he's written so well, I guess. His entire body of work has been so widely accepted over the last couple of years that he's one of the biggest writers in Norway, and it's influenced a lot of people worldwide as well. Yeah, not much more I can say about that.
Yeah, I have some questions about how applicable this is for like worldwide innovation and things. But I mean, good for him.
I mean, it's scientifically not, but it's more like, it gives voice to the unsayable, I guess, right? So more on an emotional level, he tackles topics of mortality and aging and stuff like that. So it also, on an emotional level, it hits people and it helps us deal with those kinds of things. And I do have some fun facts for him. So when he was called about it, he was both really happy and really surprised to receive the award. And he also commented on the fact that he was on the ballot, or at least the people who predict who the Nobel Prize winners are going to be. had him on the ballot for like the last 10 years, but he hadn't won, obviously. And he was honestly thinking this was never going to happen at this rate, 10 years of this, until finally it did. So he was just very happy and surprised that, finally, I guess.
Okay.
And as a young man, he was both apparently a communist and an anarchist. And lots of people thought that he wrote in his sort of the minority language, Nynorsk, as sort of a political statement. But he said it's more just that this is just the language that he grew up with, and he likes writing in, and he feels more comfortable writing in it. So that.
Okay. Well, that goes to show that it's not that it was very expected that he should win at some point.
Yeah.
So he had a real impact.
Yes, his contributions, I guess, were already known for quite a while. And I have to say, all his work has been translated into over 50 languages. So
okay, that helps. That helps a lot.
Yes, so people in different countries can also read him.
Okay. Let's move on to the next one.
Yes. So the Nobel Peace Prize was given to Narges Mohammadi for her fight against the oppression of women in Iran and her fight to promote human rights and freedom for all. Her brave struggle has come with tremendous personal costs. Altogether, the regime has arrested her 13 times, convicted her 5 times, and sentenced her to a total of 31 years in prison and 154 lashes. So she is no stranger to the fight for peace in Iran, and she's been doing this for quite a while, and it's finally good to see this person get acknowledged for all her sacrifices towards peace in Iran.
Wow.
Yes, I can give you a little bit of backstory on her.
Mm-hmm.
So in the 1990s, as a young physics student, Narges Mohammadi was already distinguishing herself as an advocate for equality and women's rights. And after concluding her studies, she worked as an engineer, as well as a columnist in various reform-minded newspapers. And in 2003, she became involved with the Defenders of Human Rights Center in Tehran, an organization founded by a previous Nobel Prize laureate, Shirin Ebadi. And in 2011, Ms. Mohammadi was arrested for the first time and sentenced to many years of imprisonment for her efforts to assist incarcerated activists and their families.
Okay.
Yeah, it's definitely intense. She's been arrested multiple times, sentenced to many years in prison, but she often got out earlier, of course. And yeah, she keeps fighting for the struggle. I believe she's currently also now in prison. And yeah, she can't see her family. I believe her family now lives in Paris.
Okay.
So this has definitely come at a great cost to her. Yeah, it's tough to comment on this, and
Yeah, no, for sure.
But it's great to see that the Nobel Prize Committee is acknowledging these people and all their struggles and the fight for peace in Iran, and more specifically women's rights as well in Iran.
A very, very heavy topic.
Yes.
Let's move on to the next category.
So the next and last category is the one in economic sciences in memory of Alfred Nobel. And it was awarded to Claudia Golden for having advanced our understanding of women's labor market outcomes. Women are vastly underrepresented in the global labor market, and when they work, they earn less than men. Claudia Golden has trawled the archives and collected over 200 years of data from the US, allowing her to demonstrate how and why gender differences in earnings and employment rates have changed over time.
Okay.
So she's done a lot of research over the past 200 years, mostly US focused, because that's a lot where she got her data, and she's also US based.
Just to be clear, the data was over 200 years and not her research.
Yes, exactly. Thank you for clarifying that. And she could see how the women's participation in the labor market has changed over time, but also the wage gap between men and women have also changed over time. And she could also link different things happening at the same time that allowed the gender pay gap to decrease, and when it actually really changed. So it wasn't just a slope that progressively improved over time, but she actually showed that it was sort of like a U curve that started out higher, went down again during the more industrial age, and then increased again. And for example, in different periods.
So the wage gap now it's bigger than it was during the industrial period. Is that what you mean, or?
Well, right now it's actually flattened out. So we're not seeing some improvements right now. She also shows that it's really dependent on, well, the different circumstances, not only worldwide, but like in different countries so developed countries have different reasons for why their wage gap is different versus non-developed countries. And as that improves, we'll see different things happening. The contraceptive pill also played a big role in reducing the gender pay gap between men and women. So it really depends on like when you're looking at it, what actually helps explain whether the gender pay gap increased or decreased. And that's also why it's so hard to explain this, because it really depends on which country are you looking at, where in the developmental stage are they, do they have access to these different things, and all those different factors. So she really helped clarify that, and that it's not a one-step policy that could really fix everything, but you really need to factor in all these different things.
Okay.
So maybe some fun facts.
Mm-hmm.
She is only the third woman to ever receive this sort of economic sciences prize, following Eleanor Ostrom in 2009 and Esther Duflo in 2019.
And also alone.
Yes.
As a winner.
Yes, for sure. So that's impressive to see. And I think hopefully we'll be acknowledging the contributions of women in economic sciences more as we move forward. But we're making some progress, I guess.
Mm.
And she was, as we hinted at previously, one of the people they couldn't get a hold on for the phone call. So the committee members had to answer the question.
Yes.
Yes.
But I guess the woman who might be in jail is the one that they might not expect during the actual award ceremony.
Exactly, yes.
Yeah.
Yeah, I don't think she's getting out.
Yeah.
Yeah.
No, makes sense.
Yes. So, yeah, quite a diverse group of people.
For sure. Okay, well, I think this was a very fun episode and a lot of fun to learn about all these different winners this year. If you like this episode, you can follow us or leave a rating on your favorite podcast listening platform. This really helps us out and makes this podcast possible. If you have any questions, suggestions, or comments, you can reach out to us via our website, thestrugglingscientist.com. You can also check out the website for some really cool science-inspired merch, and to sign up for the awesome Journal of the Struggling Scientist, aka our newsletter, where we keep you up to date with everything we're making and our fun podcast episodes. And you can also follow us on social media. Jayron, which ones are those again?
Twitter, Instagram, LinkedIn, Facebook, and YouTube.
Yes. Thank you so much for listening, and we hope to see you again next time. Bye.
Bye.